Hi, my name is Stephen McGee and I'm the author of Health Forensics. And we're here today to look into capacitive filters. And these are a bunch of 47 microfarad capacitors, and we have them on two different circuits. So this is on live 1, it's currently switched off, and we have 5 47 microfarad capacitors on this circuit. And on this circuit we have 4 47 microfarad capacitors, and it's currently switched off. So this is live 2, and we're going to look at what's going on with the oscilloscope. Now there is some more capacitors on the system, and they're at the fuse board, and there's 9 47 microfarad capacitors on the circuit right now. And before I put them on, I actually took a reading of the waveform, and I'm going to show you that waveform. So you can see in the blue, that was the waveform I had on the system before I put the 9 47 microfarad capacitors on, and the current waveform is shown in yellow, and we're looking at the grounding system of the electrical system as referenced to an 8-foot ground rod in my back garden. And the red waveform is the utility sine wave, so that's the 120 volts. And the red scale is on 50 volts per division. The yellow scale is on 200 millivolts per division, and we have a 5 millisecond per division time base. So I'm going to turn off our saved waveform. So we've got rid of the blue waveform, and what we're going to do is we're going to switch in some banks of capacitors, and we're going to see what happens to the waveform. So I'm going to start off with the bank that is on live 1. So that was live 1 bank, and you'll notice that the distortion switched over to the left. So I'm going to switch off live 1. So we've now gone back to the original waveform. I'm now going to switch on the capacitors on live 2. Now you'll notice that the waveform is distorted, and it moved over to the right this time. So that's the difference between putting capacitance on one phase or the other phase. It depends on which way it shifts the waveform. So I'm going to turn this one off, and we'll see it go back to the original waveform. Okay. So we have the original 9 capacitors on the system right now that are at the fuse board. So what I'm going to do is I'm going to put both sets of capacitors on live 1 and live 2 at the same time, and we can see what difference that makes. So they're both on right now, and that's our waveform. So I'm going to switch on a function called the fast Fourier transform function, or FFT, and we can see what our frequencies are doing. So what we're looking at right now is on the very left, that large spike is the 60 Hz fundamental frequency, and that should be there. Everything else, every other spike on the system is an artifact, and it's an odd harmonic, each one of those spikes. And you can see we've got quite a few of them. So what I'm going to do now is I'm going to switch off one set of capacitors. This is live 1 going off. So that's our waveform frequency content without the live 1. And now I'm going to switch off the live 2 bank. So the live 2 bank has now gone off, and that's what we get in the frequency domain. I'm going to switch both of them back on together. There we go. So that's our capacitance, with a lot of capacitance on the system. So right now we're looking at a system that has 18 47 microfarad capacitors connected to it. And let's go back to the original waveforms, and that's what our waveforms look like. So I don't really see any change in the voltage waveform. All the changes with the capacitance occurs on the grounding waveform. That is noticeable, and you can shift that waveform from the left or to the right, depending on whether you add capacitance to live 1 or live 2. But if you add it to both to live 1 and live 2 the same amount, you actually retain the waveform. So that was my findings with a large amount of capacitance on the home electrical system. I hope you enjoyed the presentation, and I wish you the very best of health. Thank you.